literally couldn't care less.
Okay, cool.
I do have a question that might be a dumb question.
There are
Those are the
no
What
dumb
best.
language?
questions when you're learning. Here's one thing I want people
Except
to
that
get
one.
through their head. There
You're
are
dumb.
no dumb questions when they're learning. All right? No dumb questions. Just go ahead and ask.
Okay. What language is this that I'm
This
looking
is
at right
closure that you're looking at.
now?
Oh,
Okay,
yeah.
okay, got it.
Yeah,
Closure.
that's
Okay, Danny, I
C L
remember
O
you
J
said that, but
U R E. Yeah.
okay, got it. Okay,
Yeah.
thank you.
No problem.
Yeah. Actually, here, let me oh, I'm not sharing that part. I'll paste a link into it's closure.org. Nope. Wait, that's closure.org. There we go. I'll paste a link into the chat thing. Nope, that's not the chat. Where's the chat? Is that it? There we go. I have used this program before, this web app. I know what I'm doing. Shut up.
Yeah.
um, although now that I've posted that link, I'm thinking that might not be. They don't have the best front for their language. I guess the website looks all right, but yeah. So Common
But
Lisp
as far as
is
languages, should I be learning that one? I know I should learn TypeScript, but that one doesn't seem very hard.
yeah. I TypeScript will be a lot more applicable to your jobs. Um,
Okay.
this language and Common Lisp are both probably not going to be applicable to any job that you ever get.
Okay, but just like nice, good information to know.
Yeah. Well, not directly. So like the stuff that you learn in these languages can very much apply to other to
Got it.
jobs. Like you can learn good practices that these languages do by default, and then you can continue doing them. There are things that you could do in JavaScript, but you have to be disciplined about it. And it's hard to realize it's hard to actually cash in on the being disciplined about these different practices if you're not if the whole code base doesn't do it. Like if like 80% of the code base is immutable, then it doesn't quite get you the same benefit. Like that last 20% is a big deal. And what immutable means is I haven't explained, but there's like a thing that you could do, and you learn how to do that in Clojure, and but in order to do it in JavaScript, you have to be very disciplined about it, and so does everyone else on the team doing code for whatever the project is. So like, yeah. Oh,
Okay.
actually, we did encounter it a little bit. Do you remember doing Redux? Or did you? Did you end up using Redux for state
I
management?
did.
Oh, okay.
I used Redux, but I'm not I need to brush up on it because I used Toolkit on the last two projects,
Okay.
which is
Um,
similar but different.
yeah, it's like the latest rendition of Redux.
Yeah.
It is still Redux, or at least that's my understanding. I guess I don't know for sure, but my understanding is that it's called Redux Toolkit. Um, and they made it look a lot
Yeah, it does.
more.
It is.
Oh, okay, cool. They made it look a lot more like imperative programming, even though
Mhm.
behind the scenes it actually still is the thing that I said before, immutable. Like you don't actually when you assign an object a value or a field of an object a new value, you don't actually do that. It just looks like you are. You use the exact same syntax, but behind the scenes, um, it just records that you wanted to change some field, and then
Mm.
why you might do that is it allows you to like batch a bunch of different changes together in one shot, and it also allows you to track what changes were made and make notifications to other things. And these are all benefits that you don't get unless you are 100% immutable. Um,
Mm.
yeah.
And what is this commonly used for?
The immutability. So
Yeah.
you know how React updates the web page
Hmm.
interactively, like you can
Like
change some.
dynamically.
Yeah. Um, the way that it does that is by having a virtual DOM and then a real DOM. So like a representation of all the different parts of the web page, all the different HTML tags. So like there's a div inside of another div inside of another div, usually um, inside of an HTML tag. Eventually,
That's how it works for me.
yeah. So there's the real one that's actually being displayed, and then there's a fake one, which is the one that you are modifying whenever you modify anything. And the way that
Yes.
it can
Okay.
be fast enough to be a usable product, making changes to the web page and then applying those changes, is it has to go through and figure out of all the changes you made, instead of just redrawing the entire page, what's like the smallest amount of stuff that we could change where that would uh, correctly change the old tree to the new tree. And in order to figure that out, um, they can very quickly figure out uh, what parts of the tree have changed because the only way to change a part of the tree is to actually swap out part of the tree with a new part of the tree. Um,
Hmm.
Rather than changing the actual tree, you have to create a new tree.
And replace it,
Yeah,
essentially.
and the upshot of that is, rather than having to go down the entire tree after like when you want to do an update, you only need to look at the node that you're at and see if that is different from the other one. And if it is, then you go to each of the children and look at those and see if those are different. And you can tell very easily based on the address in memory. Um, and
Like
the
a
ad
linked list. That's what
Yeah,
it
like a
sounds like.
linked list. And so if the address hasn't changed, then the content hasn't changed. So you can just
I see.
ignore that whole branch, and you don't need to keep going
Mm.
further down to look for changes. So that's
Okay.
one upshot of doing immutable is very like much faster changes to the virtual DOM and applying those changes to the actual DOM. Um, and that makes it from unusably slow, it turns it into fast enough and even blazingly fast.
Hmm.
Yeah.
I like to go fast.
Fast. I think that I have a Common Lisp Hello World. Apparently I don't have a file in here. Uh note.lisp. All right. Well, uh oh, I didn't turn on line numbers globally. What is like the minimum? Actually, I'll just do plus. Oh,
You have a a slime session open.
slime REPL.
Yeah.
Okay,
Okay.
and then
So
how do
now
I
the easiest thing is so the first thing
REPL?
is everybody talks about Hello World. In Common Lisp, since it's a REPL, right? The easiest Hello World is just print Hello World, honestly. All right. Print open print hello Hello World.
So I just did adding one and one, and I
You could
got
also do that. That's fine.
uh,
Everybody it has each of their own,
print
you know.
hello world world world.
Now, this alone, though, are each of these are expressions. Okay, they're um,
Oh,
and in Common Lisp and all Lisps altogether, closure included, um, we believe in a concept called homoiconicity. And the reason why I'm bringing this up is is because it's jarring for people from coming in from other languages, but it's a very simple concept. Basically, when you want to call a function, you say open paren function name arguments. All right? Pretty simple. All right? But if you want to call an operator, like you see above, it's also the same thing. It's operator with the arguments, like the plus operator or the times operator. This is something called prefix notation that's been used around for a very long time. It's just that it fell out of favor for infix just because that's more natural for what people see in like textbooks and stuff. But if you notice, the function name and the operator being exactly the same thing means that you can actually treat a nested expression and the precedence, if you will, like for operations and uh, function like calls, they just fall out. All right. So let's write an example. Say plus one uh, with 2 times 3. All right. So times 2, 3. All right. Here you could tell that what's going to happen is 1 is going to be added to 2 times 3 automatically. You can tell by looking at it that 2 and 3 is going to be always evaluated. When you look at infix notation, you got to remember all those rules regarding um, order of operations, right? Here, that kind of is not necessary because the evaluator recognizes this expression must be always evaluated. So the start of an expression will always be evaluated. That's homoiconicity literally in a nutshell. There is nothing complicated about it.
Um,
Another way of
so
yes.
I should mention I am familiar with some Lisps, but not Common Lisp actually working with Common Lisp directly. So, so that's my background. In case you're wondering, like, why why Rom is teaching me about Common Lisp when it seems like I already know Lisp. I don't know Common Lisp, and Rom does. Um,
What's
uh,
funny is that he's more of a better we complement each other. He's a better closure programmer than I am,
oh,
and I'm
thanks.
a better common list programmer than he
Oh,
is.
thanks.
I compliment you. You compliment me.
Yeah.
I
Um,
love that.
I feel like I should
So
explain this. Why did this show up
yeah,
twice?
go ahead
Um,
and do that. If you want me
so
to, I can.
I was gonna ask.
Yeah, go ahead.
yeah. So this printed "Hello World" and this expression has a value, and that value is the string "Hello World." Um, so this is because we told it to take an action, which is to print the string "Hello World." That's this first "Hello World," and then the second one is every time you do anything, whatever the value of that expression is, gets printed. So here, the value of this expression is 2, so it printed 2. But I didn't say print the value of this expression. I just entered this expression and it prints the value of that expression. Um,
And if
so
you
I
were to add print in the front of that, it would have printed
yeah.
two twice.
Yeah, I can. So I can actually do that. So print plus 1 1, and yeah.
Oh, cool.
So
Okay.
here, this evaluates to the number 2. Then this says go ahead and take an action on that number. The action is make this line appear. And then this whole thing has a value, and that the program that we're in, um, this the program that prints out this part, also
Mhm.
takes whatever I print here, evaluates it, and prints out the value that this evaluates to. Um, is there a better way of phrasing that where I'm not using the word value? Uh,
I see
in
that. So what I'm getting is that print is just not a part of that function's value,
uh,
right?
kind of.
Like if it's evaluating the value, it's not reading it's ignoring print, right?
The print actually returns, you could think of it as returning a value like in JavaScript
Okay.
or Python. It returns whatever this is. Actually, I'm a little bit surprised. I thought it would return the string, the number two, but I guess it returns literally the number two. Uh, is there a way,
Gotcha.
ROM, to determine that? Is there like a type of?
Type of the type of the evaluation.
Yeah, of the print statement. Can I do
Print.
something like this?
I don't believe you could do type of a print, but I've never tried that before. Just
But is
return.
there is it actually called type of? Is there something
Yeah,
like that?
it is
Oh,
type of type dash of.
type
Yeah.
of print. Let's find out. I'll just do the number two. Um,
Print
ah,
two. Yeah. Two. You could get type of two,
integer. Okay.
but it'll tell you what the expression is.
Oh,
I
and
don't
it's
know.
an
I think the return value. That's right. That's the return value. It will recognize that as being the return value of the expression, and it'll give you the type of the return value.
so print actually does it returns whatever the argument is. So
That's correct.
here we can see that the type of whatever's returned by print is actually an integer, and I'm guessing this is an
And
unsigned.
this is a 64-bit unsigned 64-bit integer.
Yeah. So
And unsigned means
it goes from 0 up to some very big positive number as opposed to some very big negative number up to
So
some very big positive.
you're gonna hear unsigned and signed a lot when you talk about
okay, I'm gonna
languages
write
that
that
are in
down.
JavaScript, because in JavaScript there's really only technically one type of number, and that is a real number or
Hmm.
or a double. In other languages, though, there are different types of representations of numbers. Integers
Like
are,
imaginary numbers.
Yeah.
yes, in some cases they do have imaginary numbers too.
Oh God, it's gonna give me PTSD.
Yeah. Oh, why is that? Now I'm kind of curious.
No, I just imaginary numbers were just I loved math. I got all A's in all my math classes and failed every history class I ever took. But no, that was one of the worst things I ever went through. That
But
and logs.
imaginary numbers weren't
It
so
just made
much.
me mad.
They made you mad.
They just make me mad. I just don't I don't like it.
Rage.
So,
Um,
it's just crazy to me because
I'll
I never thought I would ever like use imaginary numbers in my life. I'm like, why am I learning this? And now
uh
here we are.
it again. It's not very common, so you could probably
Okay,
go your whole career without ever encountering a language
great.
that has imaginary numbers built in. I will be right back. My food is done, and I'll still have my headphones on so I can
Chicken
hear you.
nuggets? Is that what you're about to say?
No, I was gonna say chicken, and then I realized it's not chicken, and I forget what
Oh,
meat it is. But it's not chicken. Um, I'll still have my headphones on, but I'll be not near the microphone, so I'll be able to hear you, but I won't be able to respond. I'll be right back.
okay. And whose screen am I looking at right now?
That is Daniels.
Okay. How long have you been programming?
20 years.
20?
Yeah, I
That's
started back in actually longer than that, 24 years.
that's
No,
crazy.
25 years. Because 1999 is when 2000 is when I started programming.
Dang. So you've just been having to like learn all of this along the way?
Yeah, I mean, my programming journey is a little unusual for most people who got into the field. A lot of folks that went into the CS program knew at least one or two major programming languages before they joined the program. They were programming since they were 11 or 12. I started programming my graphing calculator for
That's
quick
crazy.
quick answers
Yeah.
for tests to make it easier rather than me like having to like figure out certain shortcuts and stuff, so macros. And then my first real realm into programming was um, um, Pascal, which is this very old language that people forget that was at one time competing with
I've
C.
I've heard of it.
Yeah. So, I was programming in Pascal because my teacher didn't know C, but that's what was taught in the curriculum back in my day before they switched it over to Java and like after I graduated. Um,
Oh.
and so in school, my first semester was Java, but then every other semester where I went to school, I learned C++. plus plus. So,
So are you like in game dev mostly?
no. Have you ever heard of the programming language MATLAB?
I've heard of it, yeah.
Yeah, so I work for that
Oh,
company.
cool.
Yeah, 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 yeah. So that's what I do. Um, and I it's that's mainly like compiler development and stuff. But I have a passion for languages. Like over the years, I've picked up at least 17 or 18 different programming languages,
Okay, I'm
Damn.
if not
back.
more. If not
That's how
more.
I'm trying to be.
Yeah, if
I
you,
Yeah,
I didn't realize how passionate I was about coding until this class.
yeah. I
am I
mean,
back?
This
that's
is the most fun I've ever had.
Aw,
I said this is the most fun I've ever had.
that's awesome. I'm back, right? You guys can hear me?
yeah.
Okay, cool.
Yes.
Um, oh yeah, you guys should be able to also share screen. I don't know. Maybe you're used to Zoom, but like you don't have to stare at my screen when I walk away. Sorry about that. I maybe should have said that
Oh,
before I
no,
left.
that's
I mean,
okay.
I'm aware. I
Oh,
just
okay.
have nothing to share. I could share if you want me to share, but I could share. It's, uh, if you want me to like take over, like, or do some stuff, just let me
Um.
know.
Okay.
I
Uh.
mean,
Oh. What usually is there like a something one of these at the top? Oop,
1 second. What are you showing me? No, you do not need to put that in there.
okay.
So, okay, let me switch over. I'm going to my screen. So as I said last week when we were talking about Common Lisp,
Yeah.
not Clojure, I started using Alive, Karen. This is a Visual Studio extension for, um, for Common Lisp development.
Okay.
Um, if Daniel, if you have the recording from last week, it might be useful to post that somewhere. If not, we could always redo it again.
Yeah, I can post
In
it.
fact, I can redo it at
Let
some
me
point.
let me see if I can start that going right now while I'm thinking about it. My guess, though, well, so I was thinking that I would edit it, but that's not going to happen. Um, it's but there's large sections where like my computer just can't handle. I don't know what the heck
Oh,
happened. So, like in the middle
okay.
of this class, the class that Karen and I just the boot camp
Hmm.
we just finished. My OBS and my computer in general just started uh really not working very well. Like it would grind to a halt and then OBS would crash entirely. Um, but like I have years, literally years of doing using OBS with students and everything is fine. And I don't know. I don't know what the hell.
Yeah, you're not the only one I feel because that that happened to me. My microphone was like not working sometimes and working other times.
Frustrating.
Luke had to try to help me fix it, and then Alex was also having trouble
Uh,
that he said he'd never had before. So I don't know. There must be something,
something in the water.
right?
Um, where is the video? Settings. Output. Videos, OBS. That is not the right place. Dang it. Um. Oh, that's right. It was under. I think it's under Snap. OBS Studio. Current. What was last week? The 24th. January 24th.
I can't believe it's still January.
uh. Do I not have? None of these are big enough to actually be from the whole thing. Huh. Well, let me go back to the other folder um, and see. File, show, settings, output, videos, OBS. Okay, select files, videos, OBS, modified January 24th. Yeah, none of these look like they're large enough. Oh, no, never mind. 285 megs. That still seems rather small. But if anything is it, I think it's this. I I will open it up locally and then be able to tell. I know you guys can't see anything. That's why I'm like describing what I'm doing.
Thanks
Modified.
for the play-by-play.
Yup. January 24th. 285. Yeah. Yeah. Togar.
Right.
That's okay, cool. Yeah, this is it. Okay, so it's uploading, and then when it's uploaded, I'll send you a link. Oh, actually, I have a link already. I'll send it to you, and then I'll let you know when it is done uploading. Unless my computer just crashed. Hello? No. Is it actually? Yeah. Dang it.
And let's, for the meantime, switch
It's
over back to
probably
my
mad at him
screen
for trying to
here.
download the file.
Yeah, more than
Yep.
likely. Okay, so that's perfectly all right.
Confirmation.
Let's let us get back to kind
Yes,
of
I'm listening.
what we're talking about. All right. So, um, a couple things that Daniel was trying to kind of pull up that doesn't show here. You can leverage Common Lisp for various things. Like if you were trying to do what he was trying to do, which is um, create like a shell script. There's a tool that we use in that is now becoming very popular actually for creating these things called Roswell. Roswell is like a package manager for, well, not even a package manager, it's a Lisp manager that manages different Lisps. Unlike Python and JavaScript, there are different common Lisp compilers out there. A lot of them actually. Many of them are actively developed on, and as a result, to make sure that you could do what are called cross Lisp libraries, because each Lisp can write their own like little extensions, and you want to be able to like combine them into a single like unit, and a lot of folks do that. Roswell gives you the ability to like essentially test across different Lisps. I'm only mentioning this because if you ever wanted to play around with other ones when you're as you're learning, it becomes useful for you. One additional feature though that Roswell provides is the ability to create shell scripts very quickly without having to remember how to set it up for any particular Lisp distribution that you have. And to do so, you just need to create something like ROS, if I remember correctly, is ROS init hello and type in the file name that you want, and it'll create this little shell script for you. And what this does is it allows you to have like little like portions where you can initialize particular like libraries that you want ahead of time when you want to compile it. And then obviously once you have your packages and libraries all loaded up, you can actually define your main function here and then call it, and Roswell will actually compile that code and generate an executable for you if you wanted. So that way you don't have to, generate it yourself. So you could think of it like a build script for yourselves. And I
And
keep
that's
hearing
super cool.
somebody, yeah. Oh, bump the font size. Thank you. How's that?
Great.
All right. Okay. Bumping the
It's
font.
not readable on the recording that I'm doing, but if you're doing a recording, then cool.
Oh, okay. Give me a second. Did I not share my? I thought I shared my that specific window. So let
I
me
have
see.
my window set very very tiny. 20. It's like 85 columns by like 30 or so rows.
Okay, hold on one second. Window. Um. Oh, okay. I see what you're saying. Let's do that. Let me share this again, and let me uh bring this down. How's that?
That's legible.
That's good.
Legible? I, I, lo- I love. I mean, according to I mean, I'm seeing the window here myself, and it looks pretty good to me. So I don't know what the heck is going on in your stream. Uh, okay, so let me just show how this might work.
Danny got sucked into a black hole.
Yeah, I
Yeah.
can do a smaller or a larger window next time. I'm doing a small window in part because I'm hoping that that will not take down my computer. It'll take less resources.
Okay. So this is just a basic hello world script if you ever want to write it in Common Lisp. All right. Additionally, and by the way, this is not the only way to like print. I'm just showing you the simplest way to print. Like there's another utility for using format strings called format as a name appropriate. It's
Mhm.
appropriately named. And but that in and of itself is like a mini language. And requires me to like teach you like the different format strings kind of things. Like if you ever used uh in Python, they used to have this
Yeah.
print. The print used to have a something that doesn't use string interpolation. If you don't use f, you can use like those placeholders and then the percent sign. It's very
Dot
similar
format.
to that. And huh?
Yeah,
Dot
we did
format.
that.
Yeah,
We
you can
did
do
a little
dot
bit.
format too. Yeah, that's another one. But that there is another. Yeah, there's the format strings itself has a big history in a lot of different programming languages. This is just yet another
Mhm.
way of defining it. There are some conveniences with the format keyword in Common Lisp, but I won't go too much into that right now, just because it's too early for you to go into start dealing with like tabular data and printing out
Mhm.
tabular data and all that kind of stuff. That's really not useful at this point. Okay,
Tubular.
so we
Oh
talked
dang.
about expressions, which, as I said, it looks like this. This is one thing that I want to bring up on this mathematical expression stuff because of the lack of operator precedence. Just because we were talking about uh, imaginary numbers and all that kind of stuff here. Um, The S expression, which is what this is called, this open paren close paren thing, um, this actually represents in many ways what programming language enthusiasts and compiler people call an abstract syntax tree. All right. Um, an abstract syntax tree is something you're going to hear too is very often when you start getting into any of the Lisps, just mainly because if there's one feature that summarizes all Lisps, and this includes modern Lisps that have been developed in the last 10, 15 years, like Clojure, it's this one thing, which is Lisp was designed to create code generators. Like it, like if you wanted to write a code generator, like any code generator, just to treat like a DSL and make it into like a really complicated, optimized version of Lisp, or even if you wanted to Python, if you want to emit it, you could do that in Lisp in very few lines of code, and you could generate whole classes like crazy, like if you really wanted to. And just with a few lines of code, you'll be able to actually design a whole subsystem very easily. And it's a very beautiful feature to have. A lot of the stuff that LLMs kind of provide, that most people take advantage of, I would argue the stuff that they've been learning on itself is somewhat rudimentary and it's not very optimized.
To
It's great for
clarify,
learning a language. Okay.
when you say
Yeah. Oh,
class, you mean class of languages, not as in like make an instance of a class like we learned about in Python and
no,
JavaScript.
like a class, like a class definition. So if you
Oh,
think
you
of
do
in
mean
Python, right?
you can
Like if you
yeah,
you can
okay.
emit a class very easily. So like if you do def class, okay, I'm not going to show you this right now, but you can actually change how the class is getting emitted by writing something called a compiler macro in Common Lisp. And when you run that compiler macro on your class, you can have like a .py show up in your directory that is the Python equivalent. So you could compile your entire Lisp system into Python
Mm.
with
You
the
can
same
compile one
infrastructure.
programming language into another programming language. Oh, we
Right.
did that a little bit. We wrote SQLize and that generated SQL.
Right. Exactly. This
Did
is
we
it's a very similar form. It's that kind of thing.
in the boot camp? Karen, do you remember if we wrote SQL directly?
We kind of had the option.
Okay,
Um, I wrote it in the CLI, but I didn't write like you had the option on some of the practices, I think, to hard code the
the
SQL,
SQL. Yeah, that makes
like
sense.
create table and stuff like that. Yeah.
I didn't remember what was actually part of the class, and I did some stuff independently. So yeah,
Mm.
um,
Yeah. So yeah, all the days kind of blend together
yeah,
when
yeah.
you're doing code every day.
Man, I'm trying to write my resume right now in using the template that they. I find it very hard to stay on that task.
It's
I do not like
nearly
writing.
impossible.
You feel that too? That's
Oh no,
interesting.
writing resumes like literally suck the soul out of me.
Aw. Okay, well,
But I
that's
got mine
cool.
done, I think. So
What?
I don't know. Corey highlighted the entire thing when I first turned it in, so I don't know. He'll probably come back with some more notes.
Rather than this whole thing is bad.
No, yeah, he gives very detailed notes, but yeah, the whole thing was trash.
I see. Well, that's good to figure out now. Um, I hope I get.
If you want, I can show you the example that I have of all the fixes I made.
Okay. Yeah, sure. Also, we started a little bit late, so I'm okay going a little bit over the hour mark, but I want to get back to doing other stuff, even though we spent most of our time not actually writing Lisp.
That's fine.
But I'm
Yeah,
gonna
no,
let's
I'm
say,
down to meet up next time you guys are doing this.
oh, okay,
The goal is to do it weekly.
Yeah, in
right?
theory, we'll
So
do it on Friday, every Friday at this time,
at
which
this
is seven
Okay.
time,
p.m. Pacific for me. I don't know what time it is for you, what time zone you're in, but 7 p.m.
I
Pacific.
live by DC, so
Oh, so it's 10 p.m. for you.
yes, but
So
I'm a
and
night owl, so it's
ideally, it
oh,
would be
I'm in Boston,
a
so it's
1 hour
10 p.m. for
thing.
me.
fine. Oh, nice.
Yeah, you two,
11 p. It's well, it's turning on
you're
11 p.m.
practically in the
right
same
now.
neighborhood.
Practically.
Wait,
I
where are
think
you
Boston's
again?
only 6 hours from me, actually.
You're in
Yeah, so you're
DC.
like
I'm
neighbors.
I'm in yeah. I'm just below DC in Fairfax County.
Oh, oh man, that is such a small world.
Yeah.
I actually
Well,
have cousins who live in Fairfax
no
County.
way. That's
Yeah,
awesome.
I visit there significantly, like
Well,
because
next
of
time
them.
you're down, let's get coffee or something. That would be
Yeah, absolutely,
Cool.
absolutely. Now I have another fellow. Like I always like meeting lispers around the, or even people technologists around the United States because it's
well,
always fun
yeah.
to kind of meet up and just nerd out a little bit while you're there. You know.
I just love making friends.
Friends! Are we friends? Oh.
Oh man. Okay. So here's going to be my 10-minute overview with the time remaining of
Yeah.
Common Lisp, okay?
Yeah,
Very
that
10
sounds good.
minutes.
10 minutes.
I'm not gonna go through all of the stuff. We could dive into other things, but this is to get you going the quickest thing to stuff, okay? First thing we
Yeah.
talked about print. Print is good enough for you. If you need something more advanced, we can talk about that next week. Um, Common Lisp is a language that has typing, but it is what's called a dynamically typed language. But it it's a bit of a misnomer. I'll get into that because a lot of folks now are using Python type annotations. I think it's an important topic that we need to cover, but this is something that you should be aware of. Just like Python has, your ability now to like I'm just going to write the Python code and then I'm going to show you the equivalent in Common Lisp. Like add a, I think the notation is int b int, and I think you write int like this, and then you can go and write your code. Um, a plus b return a plus b. In the same way, in Common Lisp, you do have this ability: add a b. In our code, you declare them internally as fixed nums. Fixed nums is Common Lisp's way of doing integers. It's a fixed. There's a the reason is a fixed number is kind of the smallest representation of an integer, but there's infrastructure in Common Lisp that if overflow needs to occur, and for the math people in the audience, Karen, since I'm looking at you, all right, I'm gonna just say it to the math people in the audience. Um, if
That
this
was a shot
basically
at you.
means in binary arithmetic, right? There's this ability to potentially essentially roll over. All right. So like the common example is like if you have an 8-bit integer, all right, which is 250 to 200 up to from 0 to 255, you have to include 0 in there. As soon as you hit T55 and do 255 plus 1, everybody will keep thinking that 256 is can naturally be represented in an 8-bit integer. That's false. It has to go to the next level because we always start at 0. The zeroth position is 2 to the 0. So
I like the
that's
example of a car's odometer. There's only a fixed number of places in the odometer,
right.
so if you drive more than that, it rolls over and looks like
Oh.
you've not driven anywhere. You've
Right,
either
exactly.
driven a whole lot or not at all if it says zero.
Yeah. If it's a mechanical odometer, this is especially true. If
But
it's
Okay, that's
a
the
good.
digital
term
odometer,
I,
it
I
just
think
yeah,
I think that's where the term rolls over comes from.
that is where the idea of rolling over does come from. It just this is just how binary kind of works. You just got to remember that. But anyway, in Common Lisp with fixed nums, you have the ability now to allow the compiler to decide what is the biggest integer representation that I need for this particular call to this function. It's a very useful feature that other languages, for whatever reason, force you to have to make that decision up front rather than later on, based on when a function gets called. All right. So,
Mhm.
but this is effectively the equivalent of the Python code that I've written above with type annotations. You don't need to necessarily write this, and the code will still compile. But that said, most people who want to optimize code, they would add what we call type declarations, which is the with the declare keyword. All right.
Okay.
Um, Common Lisp functions are a little bit special compared to other languages in that not only do you have parameters, as you seen here, you have keyword parameters, so you can write the same thing using keywords. Okay, add with keywords. All right, and which is kind of useful. And if you're doing this, then you can design your keywords inside like so, and then you have something called this is kind of similar to what you would do in languages like say Objective C, where you can when you run this guy. Hold on, let me see, why is it complaining? um, oh, that's right. Okay, there we go. And then we can actually go in and compile both of these. I keep forgetting. uh, in Alive, you have the actual ability to actually do um, evaluations inline, which I just A one and B two. What? Oh, shoot, that's right. Hold on, this one didn't get evaluated. Okay. So the difference between the add one that you could see here and this is a little bit more declarative. Some people seem to like this style, other people seem to like this style. Positional arguments versus keyword arguments. I'm sure you've seen some of this stuff in JavaScript, maybe not in JavaScript, but certainly Python has named parameters versus positional parameters. The other thing that Lisp functions also have is optional parameters. So you can, or defaults. So let's try defaults. In this case, if you provide, um, we'll do optional first and then defaults. In this case, is we could do when b, um, actually, if b plus ab, else just return a, and get rid of that. 1 second. Oh, yeah. Add opt. Let's call that way. All right. And then in this case here, you'll see that if you don't provide um, something, it'll just return 1. But then if you provide an argument, it'll go ahead and add the two together. Okay. Pretty standard. Optional is just in some languages you have to provide just a default argument, which you can also do, but that's their definition of optional, so you don't have to necessarily call it. But we also have that in Common Lisp. So in Common Lisp, if we go here and say B0 here. Okay. Um, okay. 1 second. I forgot. I have to put the optional here with B0. This will also do the same thing effectively. So if we do this and we do add 1, you can see 1, add 1, 2, you can see 3. Um, Another thing that we have in Common Lisp that just recently got added into some languages is um, the ability to collect all the arguments into a list. So, like in Python, you may have seen something like this before. What's it? It was, I think you have to use kwargs for. Oh no, you have to use
Star star.
args. Star star. Yeah, yeah, yeah. You have to use star star. So it's def add star star args.
Yeah.
And then what you could do is you could do a reduction. Yeah, return, and you could do like a reduce here. If you ended up using like func tools, you can use the reduce functionality to actually go in and like call a function on the list of the arguments. In the same fashion, in Common Lisp, you have something called rest. So if we say sum instead of uh, args, we can actually go and write. And you don't have to worry about the code right now that I'm writing inside of it. I'm just showing you kind of like the function signatures, like the different type of function signatures that you could write, just so that you're aware of the flexibility that you have for declaring functions. Okay. I'll go through some of these more advanced forms as we go on, but this is just for the quick breeze through. So for I in args summing I. So in this example here, we have the ability to just sum numbers. So you can see that if we just say sum 1, we get 1. We do sum 1, 2, we get 2, 3. And you can see you can keep on adding as many as possible, and we'll just go ahead and collect them all into a single list, and then pass that over into the loop form that I'm using it in. Optional keyword arguments, default arguments. Okay, there are some nuances between using optional and rests and keywords that honestly, there's a great book on Common Lisp that does a better job at explaining it than I would be able to do in a short amount of time, called Practical Common Lisp. That Danny, if you can go ahead and post the Gigamonkeys link
Sure.
on
And
the chat window, that would be great.
I'm
And
gonna
then we
have
could
to
also
go
post it in YouTube.
soon. I'll
Okay.
go. I'll post that link, and then I'll head out.
All right.
Gigamonkeys.
Um.
Karen, I posted a few links into the chat, and I'm also going to post them. I don't know. I looked for you on Discord. I don't have. I don't really do Discord a whole lot, so I maybe just missed it. But I have you on LinkedIn, so I sent you messages there with the different links.
Okay. Do you want me?
Oh my goodness. Uh, I'm gonna hit stop recording.